Alright guys, welcome to our Unit 7 Quiz 2 study guide. I'll take you through some of our questions you could expect to see on your quiz tomorrow. I'll be going through 4, 5, and 6, and after that I'll do the even problems. That's what your assignment is. The other problems are included as extra practice with the answer key included at the end if you want more practice. Well, without any further ado, let's begin. Starting with number 4 here, it says use the following scenario to answer questions 4 through 6. An object is launched from a starting height of 4 feet with an initial velocity of 12 feet per second. So this is a projectile problem, and I gave you guys this little formula to answer questions about projectiles. The starting height is the h naught. The initial velocity is the v naught. So if we plug that stuff in where it belongs, we will have a formula that could tell us the height of this moving object at any point in time. So the first question, number 4, says how long does it take for the object to reach its maximum height? In other words, how long does it take for the object that's been thrown to reach the vertex? And what we want to, when we're asked how long, we're looking for the x part of the vertex. And the way you find the x part of a vertex is by doing negative b over 2a. So this is my a, this is my b, and this is my c. So negative b over 2 times a is negative 12 over negative 32. And if we simplify that on a calculator, these are calculator questions, we should end up with bring it up here. I'm trying 0.375, and that's seconds. So that's how long it takes to reach its maximum height. Moving on to question number 5. Now the question is, what is the object's maximum height? So we just found out that it takes 0.375 seconds to reach the maximum height, but now what is the maximum height? That's the y value. So to find that, all we're going to do is we're going to plug our answer there, 0.375, into this formula here, which is a formula that tells us what the height of the object is at any given point in time. So if it reaches its maximum height at 0.375, I just need to plug that in to find out what the height is at that point in time. And once again, this is a calculator question, so you're just going to type all that in and see what it gives you. And I get about 6.25 feet. Okay, so that's the answer, number 5. Moving along to number 6. When will the object land on the ground? Well, that's the same thing as asking what the roots are. If I want to know when the object lands on the ground, that's like finding the root of a quadratic function. So the way that you find the root of a quadratic function is by using the quadratic formula. This is my a, this is my b, and this is my c. So the time when it lands on the ground can be calculated by doing negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's plug in those numbers. This part, once again, I'm going to do that on the calculator. But before, when we've done these problems, we worked it out by hand, but for these ones, for the word problems, I'm going to say, let's go ahead and just use the calculator. And I'm ending up with actually a nice number this time, interestingly enough. I end up with 20. The next thing we're going to do is we're going to split this up into 2 problems. You're going to have negative 12 plus 20 over negative 32. And you're going to have negative 12 minus 20 over negative 32. Now, we get two answers because a parabola touches the x-axis twice. But I don't care about the one on the left. I only want the one on the right. The one on the right will be coming from the one where we have the subtraction, not the one with the addition. And so we only need to calculate the one on the right there. So negative 12 minus 20 is negative 32. And negative 32 divided by negative 32 is 1. And that's how long it takes to land on the ground, 1 second. Not very long. It's not in the air for very long. All right. Let's move along. Next question is asking us to solve the system of equations. In other words, we want to find out where these two parabolas intersect each other at. So step 1, or step A, is to set each equation equal to each other. And that will show where the values that they have the same are at. The next thing is we're going to take every term on one side and move it to the other by doing the opposite, so that we have nothing but 0 on one side, which allows us to do the next step, which is using the quadratic formula. Or you can factor. I think for these types of problems, you could either factor or use the quadratic formula. It doesn't really matter which one you choose to do. I'll do both methods, I guess, for the sake of the video, and you could pick which one you want to do. If you wanted to factor, it would look like this. Now, this is not the final answer, but it's getting there. When you're solving a system of equations, you solve for we're going to be solving for the x first. So notice I get two x values, and that means these parabolas intersect twice. But for each one of the x values, I would need to find the y values also. Now, that's one way that you can find the x values. But another way you can find it is with the quadratic formula. And what I like about the quadratic formula is that it always works, whereas with factoring, it doesn't always work. So I'm going to do the same. I'm going to get the same answers. So to you guys, this might seem like a waste of time. Like, why are we doing this? Well, because I want you guys to know how to do both, but you don't have to do both on the test or anything like that. So instead of factoring, I'm going to use a quadratic formula. This is my A, B, and C. And you'll see I'm going to get the same answers I got by factoring. Let me see. 30 times 4. 120 maybe? Now this just so happens to be a nice square root, and anytime you have a nice square root, that means this is a problem where you actually could have solved it by factoring, which we already know, but there's that. And then we're going to split this up into negative 7 plus 13 over 4 and negative 7 minus 13 over 4. And there's the 3/2 again, but we got it this time by using the quadratic formula, and there's the negative 5 again. So notice I got the same two answers by using the quadratic formula that I did by factoring. You're welcome to use either method you want to on this quiz. Doesn't matter, but just want you to be aware there are two ways that we can solve it. So there's that, but we're still not done, remember. That's only the x values. So I have two x values. I got x equals 3/2, and I also got x equals 5, -5. So to find the y values that go with them, we're going to plug these x values into one of the equations. It doesn't matter which one you pick. I'm going to go with the bottom one because it looks easier. So when you square this, you get 9/4. When you multiply 3/2 by 2/1, you get 6/2. And I don't care if you guys want to use a calculator or whatever, or just get a common denominator here. It's up to you. I'm going to go with common denominator approach. So I'm going to make sure they all have a denominator of 4. Nine take away 12 is -3, plus 20 is 17, so 17/4. So one of the place where these things intersect is 3/2 and 17/4. I plugged in 3/2 and I got 17/4. And then also we need to plug in the -5. For that one, I get 40. So when I plugged in -5, I get 40. So these are the 2 points where the two parabolas intersect. So step 1, set them equal to each other. Step 2, solve. So I'll write out the steps here. Set them equal to each other. Step 2, solve. Now, how you do that, you could either use factoring or you can use quadratic formula. Doesn't matter. But the last step is to plug in to solve for y. Okay, so set the two equations equal to each other, solve using one of the two methods, and then plug in to solve for y. All right, continuing onwards. I meant to be doing the even ones. Let's see, I did 7, here's 8, 9. I'll do 10 this time. All right, so step 1, set them equal to each other. And move everything over to one side. Step 2, solve. You could use quadratic formula or factoring. I think I'll just do one method this time. I'll use the factoring method. It's where you take out an x. This one has a GCF involved. And you set each one equal to 0 and solve. I went with factoring this time just because it looks a lot faster. Now you could do the quadratic formula if you wanted to. I'm not going to show the work for that, but I will tell you this much at least. The a would be 1. The b would be -7. And there is no c, so that would be 0. So you could use that for a, b, and c and use the quadratic formula. You should end up with 0 and 7. All right, but last step. Now we're going to take those two x values that we got and plug them in to one of the equations. I like the second one. It looks easier. So if I were to plug in 0, I get 5. So x is 0 and y is 5. That's one of the places where they cross. Plugging in 7, I get 12. And so when I plug in 7, I get 12. And that's the other point where these two lines intersect. On this one, it's not two parabolas crossing. It's a parabola and a straight line crossing each other. But nevertheless, we still have two places where they intersect. And so that would be the solution. All right, let's go ahead and graph this linear inequality here. When you're graphing a straight line, you start here on the y-axis. then you use your slope. My slope is 2, which means 2 over 1. I rise 2 and run 1. So up 2 from the first point and run 1, put another dot. Then I'm going to connect those dots. Now, since I have an equal sign there, I'm going to connect them with a solid line. And since y is less than, I will be shading below. Talked about how to graph these ones as well. This is a horizontal line at -5, so it looks like this. But it's not going to be a solid line since there's no equal sign here. It's going to be a dotted line. So let me redraw that. It says y is greater than, and so we'll be shading above that line. And that would be the solution to that one. Now for this guy here, for that one, that's a vertical line. And instead of shading above and below, you think of shading right and left. The right side is for greater, the left side is for less than. But I'll leave that to you guys to figure out. The answer key shows you if you need it. All right, let's go ahead and take a look at number 16. Number 16, we want to graph an inequality again, but this time it's a quadratic. And so we need to remember how to graph quadratics. All right, so to graph the quadratic, the first thing we want to do is find our y-intercept. My y-intercept is this number. The next thing I want to do is I want to find my vertex. To find my vertex, I first of all start off with -b over 2a. My b is -2, my a is 1. And I end up with 1. And then I'm going to plug that into my equation now. And that comes out to be 3. So my vertex is 1, 3. So we're going to plot those points. 0, 4, 1, 3. And since a is a positive number, that means we have a happy face parabola. So it's going to look something like this. But we're doing an inequality. Notice how there's no equal sign. So actually, I don't want to connect it with a solid line. I want to connect it with a dotted line. Next, notice that y is less than, which means I'll be shading underneath of the line, which is basically everything outside of the parabola there. Okay. And any point that is in this green area is a solution to this inequality. Anything that's inside is not. Anything that's on the dotted line would not be either because it's a dotted line. All right, one more just for practice. Let's find our y-intercept. 0, 11. Part B, let's find that vertex. So -b over 2a. b is -6. a is 1. So I get 3. Plug that answer into the equation. And I get 2. And so there's my vertex. There's my y-intercept. Let's plot those. 0, 11. 3, 2. Got a happy face parabola. So it's going to look like this. And this time we will have a solid line because there is an equal sign there. Also, since y is greater than, we'll be shading above the line, which is inside of the parabola this time. There you go. All right, last question is we're going to be asking which of these points are solutions. All right, so 2, 0, that's right here. Since it's in the shaded area, that is a solution. So I'll put yes, it's a solution. 2, 6. That's not in the shaded area, so that's no. -5, -2. I think I meant this to be -3. I'll fix it on the worksheet. But -5, -3 would be here. Now that's on the line. Now sometimes that's a solution and sometimes it isn't. If you have a solid line, then it is a solution. But if you have a dotted line, it is not a solution. All right, and that will do it. So hopefully that was helpful. We'll see you guys for your quiz tomorrow.